Ever wonder what secrets Mars is hiding? We see it in our night sky as a distant, ruby-red dot, a world of alien deserts and towering, dead volcanoes. But is that the whole story? What if I told you this quiet planet is more dynamic and mysterious than we ever imagined, holding vital clues to the history of our solar system, and maybe even life itself? We're about to take a quick tour of the red planet, looking past the headlines to uncover the real Mars, a planet of shocking extremes and amazing possibilities. From mountains that dwarf anything on Earth to the ghostly fingerprints of ancient oceans, and from skies filled with planet-covering storms to a surface roamed only by our robotic explorers, get ready to see the red planet like never before. The red planet's deceptive hues. First things first. Why is Mars red? The answer is in its soil or regolith. For billions of years, the iron-rich rocks on the surface have been exposed to solar radiation and small amounts of water vapor. It's basically the same process that causes a piece of iron to rust in your backyard. This fine rust-colored dust covers almost everything, and when strong winds kick it up into the atmosphere, it gives the entire planet its famous reddish-orange tint. But calling Mars red doesn't quite do it justice. Images from our rovers, like Curiosity and Perseverance, have shown a world with a surprisingly complex color palette. We've seen landscapes of muted golds, deep browns, and even pale greens. When we drill into rocks, we find slate-gray interiors, untouched by the rusting environment on the surface. These gray rocks are a window into the planet's original mineralogy. The polar ice caps are a brilliant white, made of both water ice and frozen carbon dioxide dry ice. And in 2024, a discovery added a new color near the equator, the faint glint of morning frost. So, while the red planet is a fitting nickname, the reality on the ground is far more nuanced, painted with a history of its long and dramatic evolution. Olympus Mons, the solar system's titan. Now, let's visit a landmark so enormous it makes Earth's mountains look like hills. This is Olympus Mons, the largest volcano in the solar system. Calling it big is an understatement. Standing nearly 14 miles high, 22 kilometers, it's almost 3 times the height of Mount Everest. Its base is so huge it would cover the state of Arizona. If you stood at its base, the slope is so gentle that the peak would actually be over the horizon. You wouldn't even be able to see the summit of the volcano you were standing on. Olympus Mons is a shield volcano built up over ages by flowing lava instead of explosive eruptions. This was possible because Mars doesn't have the moving tectonic plates that we have on Earth. On our planet, plate movement creates chains of smaller volcanoes, like the Hawaiian Islands. On Mars, the crust just stayed put over a volcanic hotspot, allowing Olympus Mons to grow to its incredible size. For decades, we thought it was just a magnificent, dormant giant. But Mars keeps surprising us. In 2024, scientists studying orbiter images found something completely unexpected on its peak. Water frost, a fine layer of frost, thinner than a human hair, forms for a few hours after sunrise in the colder seasons before vanishing in the sunlight. This was a shock because everyone thought the Martian equator was too warm and the air too thin for frost to form at such a high altitude. The discovery points to a unique microclimate inside the volcano's caldera, where air currents allow this condensation to happen. Although the layer is thin, it covers a massive area. Scientists estimate that around 150,000 tons of water equal to 60 Olympic swimming pools cycle between the surface and the atmosphere there every day during the cold seasons. This find changes our whole understanding of the Martian water cycle, proving that water is more widespread than we knew, and that even ancient features on Mars still hold secrets. The ghost of water past. Billions of years ago, Mars was a different world. It wasn't the cold, dry desert we see today. The evidence is written all over its surface. Mars was once warm and wet. Orbiters have mapped vast ancient river valleys that snaked for hundreds of miles. Rovers have driven through fossilized lake beds, where layered rocks tell a clear story of standing water. We've seen huge outflow channels, carved by what must have been catastrophic floods, and even deltas where rivers once emptied into craters. NASA's Curiosity rover found solid proof in Gale Crater, rounded pebbles, smoothed by a vigorous flow of water that might have been hip-deep. So, where did all the water go? The leading theory is that Mars lost its atmosphere. Early Mars probably had a much thicker atmosphere that trapped the sun's heat, keeping the planet warm enough for liquid water, but without a global magnetic field to protect it. The solar wind stripped that atmosphere away over time. As the air thinned out, the pressure dropped, and the planet got cold. The water either froze, getting locked away in polar ice caps and underground ice, or it escaped into space. However, the story might not be so simple. More recent studies suggest that even after Mars got cold, it may have had temporary warm periods thanks to intense volcanic activity. Huge super-eruptions in areas like Arabia, Terra could have pumped enormous amounts of heat-trapping gases into the thin air. These volcanic bursts might have warmed the planet for decades or centuries at a time, melting ice and letting water flow again before the planet slipped back into a deep freeze. This idea of a cyclical Mars shifting between frozen and brief, watery periods paints a much more complex picture of its history, a tale of two moons, fear and dread. Unlike Earth, Mars has two small lumpy moons, Phobos and Deimos. They're named after the sons of Ares, the Greek god of war, and their names mean fear and dread, a dramatic choice for the red planet's companions. Discovered in 1877, they're nothing like our moon. They're tiny and potato-shaped, some of the smallest moons in the solar system. Phobos is only about 14 miles, 22 kilometers across, and Deimos is just 7.5 miles, 12 kilometers wide. They appear to be dark, heavily cratered, and made of carbon-rich rock and ice. Similar to asteroids, their origin is a big mystery. For a long time, the main theory was that they were captured asteroids that strayed too close to Mars. This would explain why they look like asteroids. The problem, their orbits. Captured objects should have weird, elliptical orbits, but Phobos and Deimos have remarkably circular orbits right around the Martian equator, which is tough to explain with a simple capture. This has led to other, more dramatic theories. Maybe they slept of a much larger Martian moon that was shattered by an impact long ago. Or maybe they formed from a ring of debris that was blasted into orbit when a giant asteroid slammed into Mars itself. Phobos orbits incredibly close to Mars, closer than any other moon in the solar system, and zips around the planet 3 times a day. But this close orbit is also a death sentence. Phobos is slowly spiraling inward. In about 50 million years, it will either crash into Mars or be torn apart by gravity, forming a faint ring. Deimos, on the other hand, is slowly drifting away. These tiny moons are not permanent fixtures, but are living out the final acts of their cosmic story, the planet's shrouding storms. Mars may not have rain or snow, but it has its own dramatic weather, dust storms on an epic scale. These aren't just little dust devils. Martian dust storms can grow to the size of continents, and sometimes, they merge into one massive storm that covers the entire planet in a dusty haze for weeks. These storms happen because Mars is covered in incredibly fine dust. During the southern hemisphere's spring and summer, the planet is closer to the sun, and the extra heat drives strong winds. When these winds get going, they lift the fine dust high into the thin atmosphere. What we don't fully understand yet is the trigger that causes some of these storms to go global. Because the Martian air is so thin, less than 1% of Earth's atmospheric pressure, the wind itself wouldn't feel as strong as a hurricane. But the dust it carries is a major threat to our technology. The fine, slightly static dust gets into everything. For a solar-powered rover, a global dust storm can be fatal. As dust fills the sky, it blocks the sun, and solar panels can't generate power. This is exactly what happened to NASA's Opportunity rover in 2018. After 15 amazing years of exploring, a planet-wide dust storm blotted out the sun, and Opportunity, unable to recharge, fell silent forever. A planet of robots. For now, Mars is a planet of robots. These robotic geologists and chemists are our eyes and hands on another world. From the first rover Sojourner in 1997 to the workhorses Spirit and Opportunity, each mission has pushed the boundaries of exploration. Today, the surface is home to some of the most advanced rovers ever built. NASA's Curiosity and Perseverance. Curiosity landed in 2012 and has been studying the climate and geology of Gale Crater, famously confirming it was once a habitable lake. But the star of the show right now is Perseverance. Landing in Jezero Crater in 2021, its mission is to search for direct signs of ancient microbial life. Jezero Crater was chosen because it was once a lake with a river delta, exactly the kind of place where evidence of life might be preserved. Perseverance is also a collector. It's drilling rock cores, sealing them in sterile titanium tubes, and dropping them in caches on the surface. These tubes are part of an ambitious plan called Mars Sample Return, where future missions will retrieve these samples and bring them back to Earth for study. Perseverance has also set records for autonomous driving and even brought its own helicopter, Ingenuity, which performed the first powered flight on another planet. Every Martian day, or Sol, these robots are rewriting the story of Mars. paving the way for the day human footprints join their wheel tracks in the red dust. The thin air and extreme seasons. Standing on Mars without a spacesuit would be a very bad, very brief experience, mainly because of its atmosphere. The Martian air is incredibly thin, the pressure is less than 1% of Earth's. It's also about 95% carbon dioxide, with almost no oxygen. This thin atmosphere can't hold on to heat, which is why Mars is brutally cold, with average temperatures far below freezing. This thin air also leads to extreme seasons. Mars has an axial tilt, just like Earth, which causes seasons. But its year is much longer, about 687 Earth days, and its orbit is more oval-shaped. This means that during its southern summer, Mars is much closer to the Sun, leading to short, hot summers in the south and long, cold winters in the north. A Martian day, or sol, is about the same as ours, at 24 hours and 37 minutes. But the seasonal cycle truly defines the planet. In winter, it gets so cold at the poles that carbon dioxide from the atmosphere freezes and falls as snow, forming a seasonal dry ice cap. In the summer, that cap turns directly back into gas. This process causes the entire planet's air pressure to swing by as much as 25%. Over the course of a year, a kind of planetary scale breathing that happens nowhere else in our solar system. The story of Mars is still being written with every new image and every rock sample. From finding frost on equatorial volcanoes to robots searching for signs of past life, the red planet continues to surprise us and fuel our curiosity. If you enjoyed this trip to our planetary neighbor, be sure to hit that like button, subscribe for more explorations of our universe, and share this with anyone else who wonders what's out there. What we've learned has only made Mars more alluring. It's a record of our solar system's history and a world of stunning beauty. It reflects our own planet's past and points toward humanity's future. The robots are there now, but one day we will follow. The greatest discoveries on the red planet are still waiting.